Okay, back to ground rules. Discussing LivePremier, we're going to talk about LivePremier, that's it, no other screen switchers. LED systems, they're all open for discussion. Email solutions@Evolve Media Group with the subject LivePremier for LED, and we will send you the presentation after we're done. So you'll get it as a PDF. Send it to that email group with that header. Basically, there's a filter in place to look for the header to send it back to you. Those are the ground rules. We are 2 slides in, 119 more to go. Analog Way Simulator. The simulator is out, it's functioning, it works really well. It allows you to customize the hardware. It does not require VirtualBox or anything else to install. It's just on the Windows side, it's an EXE. The Mac version is out. The version number, when I checked last night, was version 1.06. If you plug in the simulator and run it, you can follow along with the examples. They all will work. LivePremier. What is it and what makes it unusual? So the LivePremier platform is optimized for 4K. It is 4K all the time, every day, all the places. So the SDI inputs and outputs, they're all 12G capable. They are broadcast standards and cinema resolutions. So 16:9, 16:10, and the cinema resolution, so the 4096 wide. Every input and every output is capable of 12G. HDMI, the HDMI is HDMI 2.0. You can do SMPTE outputs, you can do VESA standards, and you can do custom formats. And they can be either dual link or 4K. DisplayPort 1.2, all the DisplayPort ins and outs. There's SMPTE, VESA, and custom formats available, and they can also do 2K and 4K. What is a standard EDID versus a custom EDID? Just so you know where I stand on this, I am on the I like custom EDIDs. I like to maximize the pixel space. I like to maximize the usable space, and we'll show you where that can come in handy in LivePremier. So the VESA standards are consumer standards. They are your monitors, your, hey, we created a new monitor with a new funky resolution, and this is what that resolution is. SMPTE standards, motion picture and broadcast, they're very slow to change. So they build a standard, they create a standard, and it stays a standard for a long, long time. So that's the difference between the VESA and the SMPTE standards. Most of what we do with LED is going to be VESA standards or custom EDIDs. So on the left-hand side, there are some standard formats that are VESA standards, 1024 by 768, if you're old enough to remember XGA, 1366 by 768, 1280-720, and then on the right-hand side are some SMPTE formats that are similar-ish, 1920 by 1080 I and P. Today we're talking about LED. I is not your friend. 2048 by 1125, 2048 by 1080, cinema resolution 4096 by 2160, 4K cinema type resolutions, 3840 by 2160 UHD is a VESA standard. So these are standard SMPTE standards and VESA standards. Standard EDIDs versus custom EDIDs. So there are single link, which is your 165 megahertz clock rates, dual link, 330 megahertz, and 4K, or what in LivePremier they call capacity 2 standards, and that's a 600 megahertz clock rate. So this is some examples of single link versus dual link versus 4K. LivePremier is 4K first. It does 4K all the time with no problem. The minimum output capacity on LivePremier is dual link capacity. It's called capacity 1 in the current firmware. So anything with a capacity 1 is dual link and is going to fall under this 330 megahertz clock rate. Dual link is not available on SDI. There are some 6G standards that are available on the SDI output connector, but you have to set the connector capacity to capacity 4 to get those 6G output standards. To maximize the scaling capability in LivePremier, you really want to stay with either dual link or 4K on the output side. It's not inputs, it's on the outputs. It's to maximize the use. The other tool we have for resolution and creating custom sizes and custom screen sizes is area of interest. So area of interest constrains your screen to a specific subset of pixels inside the raster of a standard display space. When you set up an area of interest, what you see in the simulator and what you see in the web RCS is the actual surface. So when you go full screen with a layer, it goes to the edges of the area of interest. It doesn't go all the way to the edges of your actual raster. Area of interest works on any output connector type. So it works with SDI, it works with DisplayPort, it works with HDMI. Not a problem. It is connector based. It's not screen based, connector based. So if you have multiple connectors on the screen, each connector can have a separate area of interest to make a total canvas output, and each one can be as a little separate area of that canvas. And you build your area of interest on the output in the canvas setup section. We're going to do that in a few minutes. So this is an example of area of interest. I have a 1920 by 1080 raster, and I'm constraining it to 500 by 700 pixels for the area of interest. That's, a very typical, I take a standard resolution, standard output size, run that to my LED processor. My LED wall is positioned at 0, 0, the upper left corner of the raster, and I'm making the LED wall 500 by 700. Now when I'm working on web RCS and with LivePremier, my layers are inside that 500 by 700 box unless I force them outside of it. Custom EDIDs are different from area of interest. Custom EDIDs and custom formats are two different things, but they are interrelated. An EDID comes from a display device. So for instance, on the front of an LED processor or in the LED control software, if you set the screen resolution, for instance in Novastar on the sending tab, if you go to custom resolution, that's creating an EDID that sends the information back to LivePremier. You can also create a custom EDID offline using the Analog Way EDID editor tool. It's available on that same software section of the Analog Way website where the simulator was. You can also create a custom EDID based on a custom format, and I'm going to show you how to do that. Custom formats and EDIDs differentiate. Basically, a EDID maxes out at 4096 wide. Custom format can go wider and taller than an EDID. And it's not dependent on a source. It pushes the pixels out regardless of what the EDID is. Interlaced EDIDs. We never want to use interlaced with most LED processors. About the only time you would want to take an interlaced signal to an LED is if you're going to a processor that has a built-in scaler, because LED displays by their very nature are not interlaced. They are progressive displays. They show you everything. You run an interlace signal to most of them, what you will see is every other line of pixels will turn on. When you're building a custom EDID, one of the options you're going to see is called reduced blanking. Usually you want to turn this on. It gives you the ability to have a slightly larger active pixel area inside the total raster, and the port capacity may calculate incorrectly if you do not have reduced blanking on. Yes, and William is mentioning you can use the EDID editor to rename EDIDs to something less obscure and more human readable. Excellent point. So custom formats. So custom formats exist in the LiveCore and also in the LivePremier platforms. It's not an EDID. An EDID is limited to 4096 horizontal, and it comes from a display to a source. A custom format can be up to 8192 horizontal and 4320 vertical. It is limited by the pixel clock, that 600 megahertz clock that we talked about earlier. Preferably a custom EDID, or a custom format rather, should be, the width should be a multiple of 8. It's maths. You can make them different than that, and the custom format generator in LivePremier will correct you, I am told, if you're in simple mode. If you're in the advanced or full settings, you can force it to do other resolutions. One thing about that multiple of 8, your LED wall is most likely a multiple of 8 as well, as far as its panel resolution, because that's how LED driver chips work. So the LED driver chips play nice with multiples of 8 pixels, so 8 or 16. So it all goes back to 1, 2, 4, 8. Oh, look, it is a nice binary number. 12 is not a nice binary number. Custom formats will not work with the SDI outputs. So that's something you need to know when you're planning a show and you're like, oh, I'm going to use custom formats. If you're doing SDI outputs, you're going to be limited exclusively to regular formats and area of interest. So LivePremier output cards, they are interchangeable. They are very easy to swap out. Step number 1 for swapping an output card: power off LivePremier, unplug it, and wait a minute or two. Let the power supply discharge. Do not hot swap output cards. The output card itself is actually fairly small and doesn't have a lot of processing on it. Very simple to change out, and you can swap out SDI, DisplayPort, HDMI cards. They can be in any slot in any order, as long as you start at the top and work your way down. If you're using SDI outputs, you can only do area of interest. If you're you can't make a custom format, you can't force into a for instance, a wider and slightly shorter format type with SDI. HDMI and DisplayPort, you can use both area of interest and custom formats and custom EDIDs to get whatever size and shape your LED display is. Let's look at some LED side of this equation. So that's all the LivePremier hardware. On the LED side, here's some LED cabinets. A couple of different brands here, and these were picked mostly because people have run into them. So on the left we have some Abson cabinets. On the right we have some row cabinets. And we have the horizontal and verticals. Those are the horizontal and vertical pixel space of those particular cabinets. So for instance, the AT3 in Abson is 160 wide and 320 tall. On the row side, the CB3 is 160 wide and 320 tall. Those two cabinets happen to be exactly the same dimensionally, pixel-wise. That's the kind of pixel space you're looking at. The M29, 168 by 168. The Black Pearl. The Black Pearl 2, 176 by 176, so that's a square cabinet. On the bottom here, we have Novastar and Brompton and some comparisons between the processors, the senders. So Novastar, the 660 Pro, the R5, the 4K, and the UHD Junior. And on the left, we have the Brompton, the S4, the M2, the S8, and the SX40. So let's look at these. The 660 Pro, this is not the regular 660, the 660 Pro. It has HDMI and a 3G input, no scaling. The S4 from Brompton has a DVI input, no scaling. Max between the two, 2.3 megapixels on the Novastar 660 Pro, 2.1 megapixels on the S4. Roughly 2 million pixels. That's HD. That's 1920 by 1080 roughly. The R5, it has a 4.6 megapixel input space. And these are input resolutions. So 4.6 megapixels on the in. It has an HDMI and a 3G connector. It actually has a 6G connector. That's a typo on my part. No scaling. The M2 is 2.1 million pixels. If you look down to the S8, it's 4.5 million pixels. It's pretty much comparable to the R5. It has a 12G and will downscale the 12G. The R5 has no scaler, so it has a 6G in. And you notice the Bromptons, their real tour de force is the power of their scalers. The MCTRL 4K, 9.2 million pixels. We've doubled from the R5 up to from 4.6 to the 4K at 9.2. It's got an HDMI, DVI, and DisplayPort in. No scaler. The big processors from these two companies, the large processor from Novastar is the UHD Junior, and now there's a UHD Pro. 9.2 million pixels, so it's a 4K processor. Has 12G in, HDMI, DisplayPort, and a scaler. The SX40, 9 million pixels, 12G, HDMI in, and a scaler. So let's go look at the inputs, and I'm going to show you why you probably want to lean in one particular direction. So Novastar, input options, HDMI, 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 HDMI. Every single processor on this sheet has an HDMI input. On the Brompton side, we have DVI, DVI, HDMI, HDMI. DVI, HDMI, very, very common across all LED processors. Highly usable. Most LED processing has either an HDMI, which will take a DVI signal via an adapter, or a DVI plug itself. SDI, 3Gs, 12Gs, 12Gs, 3Gs. Lots of these have SDI inputs of either 3, 6, or 12G. Perfect. DisplayPort. Out of all of these processors, only the MCTRL 4K and UHD Junior have a DisplayPort in. What that tells me is avoid DisplayPort as your connector because most processors don't have it. So if you're designing a LivePremier or planning a LivePremier purchase or planning a rental, specify, hey, I need HDMI or 3G output card or HDMI or SDI output cards. All of the output cards in LivePremier, the SDIs are all 12G, but that's the connectors you probably want. The DisplayPort connectors, not that useful in LED world, just because the processors, the senders, the controllers don't have a DisplayPort connector. Yes, SDI. SDI is great for being able to transit long distances, and SDI works fine. Just the limit is if you do really wide displays, you're going to end up using a lot more SDI connections because the SDI doesn't support custom formats. When you get into doing really wide displays, greater than 4096 pixels, the controllers support wider input spaces, but you've got to bring it in on an HDMI connector. Next tool, and this is another free piece of software that most of you have heard of, FidoLED. FidoLED is a freely downloadable tool for Windows Desktop. There is an iPhone and an Android app that you can pay for. It's maintained by one of the guys from CT. Huge database of LED tile info. If you're programming LivePremier and they say, well, it's 12 tiles by 8 tiles, 12 wide by 8 high, and it's going to be absent M29, and then you're flying out and you get a message and they say, oh, well, they swapped the tile for blah, blah, blah. You have to go look up, where do I find the tile info? FidoLED is by far the fastest, easiest, most convenient way to find info, especially on tiles that you've never heard of. If you're working internationally and you've never heard of this brand, believe it or not, it's probably in FidoLED. Supports ongoing database updates. It creates PNG, pixel accurate PNG pixel canvases. So you can use those as backgrounds in LivePremier, and we're going to do that. It is free on the Windows desktop, and there is a paid app on iOS and Android. Download and use it. We get nothing from the guy who maintains FidoLED. It just is a tool that works phenomenally well. SDI equals a lot of lag without Genlock, I have found. Well, no lag. I don't know what you mean by lag. Where are you talking about lag? Inside LivePremier or inside your LED controller? The LED on the Novastar side, unless there's a scaler involved, there's virtually there's between 1 and 2 frames maximum, and if you run in low latency mode, you can eliminate that hugely. Yes, that's the link for FidoLED. That's also at the end of the presentation. There's a slide with all of the web links for everybody. So, LivePremier. How does it, what does it work? What does it use? Why is it great for LED? So in the LivePremier, you have a VPU. You have 1, 2, or 3 VPUs depending on which chassis you're working with. One VPU in LivePremier is 40 million pixels. At 60 Hertz, at 444 color space, at 10 or 12-bit color. So it's really 40 million pixels all the time. On a VPU, one single VPU with 40 million pixels, you can get 4 4K mixing layers. So that's 4 outputs of 4K. Each of those outputs can have 1 4K mixing layer, or 1 output at 4K with 4 4K mixing layers, or mix and match. You can have a maximum of 8 dual link mixing layers, or a combination of both. So if you have 6 dual link layers, you still have 1 4K layer left over. So you can mix and match capacity 1, which is dual link, and capacity 2, which is 4K. You can mix and match the layer quantities any way you like, with some restrictions. You can also do split layers, non-mixing layers, that will double the quantity of layers. However, you cannot do both split layers and mixing layers on the same screen. So on a screen, you either have mixing layers or split layers, not both. Split layers are great for exhibit booths, permanent installs, command and control, where you're not dissolving back and forth between sources. You're literally putting a pip up, and then another preset is a whole bunch of other pips up on the screen. That's where split layers are really handy. So exhibition booths where things are coming and going on the screen without having to transition between sources, split layers work fine. So remember this, 4 4K or 8 dual link mixing layers. Everything I'm doing today is going to be all with mixing layers, because that in a live show is principally what we're asked for. So here is a single screen with 3 pixel spaces. These are 3 physical LED displays. And the question is, what's the minimum number of output connectors? So how many output connectors do you need to do this display? Agree, Kurt. We all love FidoLED. So what is the first question you need to ask when determining how many output connectors? Well, the first thing I would ask is, what signal format are we using? Because that does make a difference. So which output connector do you want to use? Sometimes people want, clients want control in another building, control inside the broadcast truck, and you've got to come out of there and it's got to be SDI. So if this screen was being used and driven entirely from the SDI connectors, well, these sides are 1920 tall. So that exceeds 1200 tall, which is the maximum you can get on a, well, I could go, actually this is an error. I could do a 4K, a 12G output connector at 2160 high and make these sides work. So I'd need one connector for each side. So 21, they're more than 1200, so one at 2160 each. The center is more than 4096 wide. That's the maximum width you can get on one 12G connector. So I'm going to have 2 UHD 2160 outputs for the center. So 1 output for each side and 2 outputs for the center, 4 total outputs with SDI. The other option, HDMI. I'm not going to look at DisplayPort because DisplayPort's not that common in LED processor inputs. On the sides, same thing, 1200 high, so there's a 4K 2160 for each of these 2 side screens. Center is 4096 wide, so more than 4096 wide, I need 2 output connectors to drive that. So I need 4 output connectors. 4 output connectors is 4 processors. 4 processors, 4 separate pixel spaces. You're going to use all the outputs from, 4 outputs from the LivePremier output section. That could be all from 1 card or from multiple cards. But is there another way to do this? Of course there is. So if we go to HDMI and we use custom formats, the sides can be 1 dual link connector each, and the center is 1 4K connector. So this goes from being the left and right side at 1920 tall go from needing a 4K capacity to needing a dual link capacity. And then the center goes from needing 2 4K outputs to needing 1 4K output. So we go from 4 connectors to 3, and you'll see that the sides, even though they're coming out now they're coming out as dual link, you don't need 4K senders any longer. So you can do this with other processors that are less difficult to find, less expensive if it's an install. So this is a screenshot from the custom format page in WebRCS. I'm going to zoom in here. And up here, so I've created a 1920 vertical. So it's 1080 wide by 1920 high at 60. And the little number tells me that that has a capacity 1. So it's a dual link capacity. And M2 here is 5760. It is 5760 wide by 1080 lines high. It has a capacity 2. So it's wider than that 4096, but because it went shorter and stayed inside the pixel clock, if we look over here, here are all the specifics about it. This ends up being a 4K or capacity 2 connector. It fits in that pixel space. So that makes the HDMI connector a little bit more flexible in the SDI. Let's go ahead and switch over to the LivePremier. So this is, I am physically connected to an RS4. So if I go into custom formats over here, and this box already has a bunch of custom formats, how do you create a custom format? So over here, you can either start from an existing memory, and this will pull up all the custom memories. You can start from a template, or you can start from an EDID. Any one of those works fine to create a custom format. I'm just going to start from, start from a blank EDID. We're going to do, let's do the 1080 by 1920. So I'm going to give it a name, 1080, so I can name it. Next piece here, we have mode, either CVT, where I just have to put in the rate, the horizontal, and the vertical, and that's it. Or I can do full, where I put in all the specifications for the sync, the back porch, the front porch, the polarity. For now, I'm going to do CVT because it's fast. So 1080 wide, refresh rate of 60 Hertz. Going to turn reduced blanking on. So horizontal timings, if I double click in there, I can type it in. So it's 1080 horizontal. The vertical timing is 1920. Once I've done that, I click on check, and it returns, hey, you are successful. This is a valid timing that will work. Number 1 means it has a capacity of 1. Where do I want to store it? I'm going to store that in M7. I click save. There it is. And then when you click on any of the saved formats, it gives you all of the detailed information. So remember, this isn't an EDID. This is a custom format. And this allows us, because this is a portrait screen, a vertical screen space, instead of having to use 2 landscape format images or a 4K pixel space that we're only using a small portion of, we can actually build this display. Now if I go in here to Canvas, I'm going to make a new screen. So I'm going to go to Screens. I'm going to make a new screen. Enable it. I'm just going to drag any HDMI connector that's not in use. So these 3 connectors are being used by a screen already. So let's grab this one. Grab this connector. It's capacity 1. Perfect. In order to make a screen in LivePremier, you have to add at least one layer. Layer capacity 2 or layer capacity 1, doesn't matter. This screen is only an HD screen. I'm not going to downscale any 4K content to it, so I'm just going to add one mixing layer and go apply. So I've added one layer to it. Now I can go to Canvas, pick my screen 2. Here's my output. And if I go selection up here, and this is where you assign the format to that, custom formats that are available to that capacity connector show up at the top of the list. And the list is fairly extensive. And we just saved that 1080 here in memory 7. Watch what happens when I select memory 7. Gave it a second, and the canvas space automatically adjusted to match the pixel space of that custom format. So I don't have to do any area of interest. I don't have to do anything else except apply the custom format, and there's my pixel space. That's why I like custom formats sometimes better than area of interest. I don't have a big rectangle of extra pixels that I'm not using. It just creates the canvas space, applies it, and I'm all good. I can still go in if I wanted to trim this. Let's say the carpenters made the surround a little bit big and it's cutting off pixels and you don't want to lose them. If you click here and then you come down to region and go custom, and this is where you set area of interest. And again, remember we said area of interest is per output. So you can drag your area of interest around, and notice while I'm doing changing the area of interest, the canvas space is changing it automatically at the same time. Very, very fast. This works in the simulator, so you don't need a live device. It also works, obviously, on a live device via WebRCS. If you want to specify the pixel space, you can click on horizontal and vertical size and type in whatever the size you want is. But that's why I like using custom formats as opposed to area of interest for some things. I find it easier to work with. So let's go back to the PowerPoint and jump into the first exercise. And this is building on all the topics we've kind of been discussing so far. So, pixel space, 2560 by 1600 HDMI source. So we have an HDMI source coming in, a single source, at 2560 by 1600. Not three separate sources. We have 3 display walls, and the individual content is, for each wall, is mapped inside that pixel space. So the walls are 1024 by 768. There's 2 of those, and there's one that's 800 by 1080 tall. The traditional method of doing this kind of setup is 3 outputs, set each output at 1920 by 1080, arrange them on the canvas, and create an area of interest. And that is perfectly acceptable and works perfectly fine. So to do that, we need the starting coordinates of each of our pixel spaces. So our upper left corner starts at 0, 0. Our bottom left screen starts at 0, 832. So X is the first number, Y is the second number. Everything is related to the upper left corner. And then pixel space 3, our third LED wall, is at 1600, 200. And that's, again, the upper left corner of that space. So now we're going to look at how we would build this in WebRCS. So here is a shot from the WebRCS configuration. So I created the screen, gave it a name, assigned the 3 outputs to the screen. So I've got the 3 outputs set up here. Then I've added layers, and I've got 4 layers on here. So I have 3 capacity 1 dual link layers, basically 1 for each of the 3 specific pixel spaces. And then I've got a capacity 2 layer that covers all of the pixel space. So that could be that 4K source coming in, or anything with a capacity 2 input coming in and filling that entire pixel space. And if you notice, I've got layer 1, 2, and 3 are all the capacity 1s. Let me zoom in on this for you. So layer 1, 2, and 3 are capacity 1. Layer 4 is the capacity 2. Layer 4 is sitting on top of the other 3 layers. There is no Z-order rearrangement currently, so the way you assign the layers is the way they're going to stack up. So if I bring anything in on layer 4, it's always going to sit over on top of everything, and that's fine because that would be a content piece that's going to stretch across all 3 LED displays. After you assign outputs to a screen and you assign layers to a screen and you click apply, you then go into the canvas, and in here I've created a custom canvas size of 2560 by 1600. I have my 3 outputs. Then after you create the canvas size, you need to go into each output and you set an area of interest. So I've picked, for instance, in my slide here, I picked the 3rd output. It's at 1600, 200. That's the upper left corner. So there's the horizontal position of that output. And then I went into the area of interest and I set the area of interest at an 800 by 1080 size. So there's my area of interest of that output in where it sits in the pixel space. So I have up here is our 3 outputs. Output 1 is 1024 by 768. That's the area of interest size. Output number 2, this output 7 is the physical output connector. That one's 1024 by 768. And if we look down here, it's at 0832. And then the final output for this canvas is still a capacity 1. It's an 800 by 1080. And its position is 1600 by 200. So that assigns all of the outputs to the pixel space. So we have 3 outputs, 1 screen, 3 connectors, area of interest, we're good to go. There are some issues with this approach in LivePremier. This would be a traditional approach that a lot of people have used over the years. There's nothing wrong with it. The issues are there is no single input native background. A limitation currently in LivePremier is for a single input or a single image to be a native background, it can only be assigned to 1 output connector. So an input or an image that is a native background can only be assigned as the native background on a single connector. And this methodology requires 3 outputs and 3 LED processors. Each output is only an HD pixel space. It's capacity 1. LivePremier is, at its core, a 4K switcher. All of the connectors, their lowest setting is dual link, capacity 2 or capacity 1. all of this is running at HD, half of that. So there's a lot of capability in LivePremier that's not being utilized to the most efficient way. Let's talk about an optimal workflow for this same example. First step, create a custom format. Your original format, 2560 by 1600, let's see how much space that really needs to work. Determine the best processor for the format, apply that format to an output connector, and then your layering stays the same, but you now can do, if it fits on one connector, you can do a single input native background and a single image native background. So let's look at how that goes. So here is custom format, and let's zoom in. We are doing 2560 by 1600. That's the total canvas resolution we're using. And it says that's a capacity 1. That's a dual link capacity. Think back to the slide with the Brompton and the Novastar senders on it. That means this will work with an R5 or a 4K on Novastar, and this will work with the dual link Brompton processor or any of the bigger ones. So you have much wider flexibility in which processor, which controller you're using, because you only need a dual link. So this would come out of an HDMI connector with a custom format. If you were doing this on SDI, you'd end up doing single connector and having to use capacity 2, because even if you use the 6G output formats, they are, I'm told, they're only available when you set the SDI connector to capacity 2. So, after I create a custom format, oh, sorry, wrong way. How do I apply that format to the output? Same way we did previously. So, in here, I've selected the output connector, and then the drop-down shows there's my 2560 custom formats. They appear at the top of the format list, as long as the connector capacity and the capacity required by the custom format match, or the connector has a higher capacity. So you can apply a capacity 1 custom format to a capacity 2 connector with no problem, but you can't do the reverse. The connector capacity has to be equal to or greater than the format, and the frame rate has to match. We had an interesting dance the other day and this morning working with the switcher we're using, which does not have a scaler, so it requires 59 Hertz frame rates, and laptops that want to do 60. Laptop's not working, laptop's not working, frame rate. Oh, there it is. So same here, the all these are set at 60, and the internal frame rate is set at 60. So the connector frame rate is following the same frame rate as custom format, and the capacity is equal to or greater. Let's talk about, so I've created this 2560 by 1600, and I want to put that as an EDID on my input side. So let's go ahead and go to the live web RCS machine. And here in the live web RCS, let's walk through this. So formats. Let's create a new format. So we're going to call this one 2560. 60 Hertz, I'm leaving it there. Reduce blanking, usually leave that on. Horizontal active, 2560. Vertical timings, 1600. So 2560, 1600, check. It says capacity 1. Excellent. I'm going to save it there. So I've created my custom format. We're all good there. Next step, let's go to EDIDs. This is the EDID library. So up here at the top of the EDID page are all of the factory EDIDs. If you hover over one, it will show you, I'm on AW2, and all the ones on the side are the input connectors that are using that current EDID. And you can scroll through the list and see which ones they are. So here's all of the physical input connectors on this RS4 unit and which EDIDs are being used where. So this is an HDMI source that I want to use. So to create, we created 2560 by 1600. I'm now going to apply that as an input EDID. To do that, I have to turn it into an EDID. It's not one yet. So I'm going to take this Aquilon HDMI standard and just drop it into an EDID block. So any block, doesn't matter which one. Click on the three little ellipse, the hamburger menu as some Android people call it. And now I can do a custom format and apply it as an EDID. So memory 8 is my 2560. So I'm opening memory 8. I'm going to give this a label of 2560. Enter. I'm going to apply this as the EDID. Enter. So I'm just clicking on apply as an EDID. So now that is the Aquilon HDMI 2560 by 1600 at 59.99 hertz, and it's called 2560. Now this is available for me to apply to an input connector. I want to go look and make sure I don't apply it to any of our active inputs. So, yep, 1 and 2 are clear. So one of the really cool things about the LiveCore interface, so I'm going to click on input 1. I can't change the EDID from this page, but it does tell me what the active EDID is. And notice category and EDID are both blue. They're hyperlinks. This is all HTML5. So if I click on EDID, that jumps me right to the EDID page. Connector 1, I'm going to take this 2560, drag and drop it on top of connector 1. Now if I go back to my output page and connector 1, doop. Input. Oh, sorry, input 1. Yes, let's go to the right page. Aquilon HDMI 2560 by 1600 at 59.99999. So that's how to take a custom format inside of the WebRCS. We just did this live. Save the custom format, turn it into an EDID, and apply it to an input. It takes longer to tell you and walk you through it than it actually does to just do it. Very fast, very easy, no external tools. You can also import EDID files if you want from any standard input. An EDID is a standard .bin file, and you can import standard EDID files in that same menu. So that was create a custom input. Now my laptop or whatever the computer source is going to see exactly the same pixel space as my output on their input connector, so they don't have to force the card into doing some custom resolution. You can help the graphics people by going, here, I'm going to tell your computer what I want it to do. So if we go back to the lovely PowerPoint. So this is just going to walk through what we just did. Drag and drop a factory EDID into an empty slot. Click the ellipse or the hamburger menu. Select the custom memory. select under memory the custom format that we use. We did memory 8, I think it was over there. Apply to the EDID, and then drag and drop that new EDID into any of the inputs that you want that to be working with. So that is custom formats and custom EDIDs, all to get this 2560 by 1600 screen. Native background. So I want this to come in as a native background so that everything is positioned correctly. That one 2560 by 1600 source has all 3 pieces of content positioned exactly correctly. So if I want to do this with an image, I have to select the slot, assign the slot, the image slot, not the library where the stills are all stored, but the slot where I'm going to use it from, assign that as a background, then create a background set. So let's go back to the WebRCS. One of the cool things with the simulator is this also works in the simulator. So you can actually load images into your simulator and use them. So I was loading some PNGs into a simulator session. Yeah, so I'm over here. So let me go into, I'm going to start up the simulator. So I have the simulator running. I created a session, which I then saved. I call it webcast. And you notice here in the simulator, you have all the different model options available. So very quickly, just going through these. The RS Alpha, this shows you what an RS Alpha is. It's a stock configuration from Analog Way. This is how it comes. It has one VPU, one IPU, and it has these input and output connectors. And then the RS 1, 2, 3, and 4 all are standard configurations. One of the things with the RS configurations, as you look in the simulator, you will see all of the output cards are always HDMI. It's a sticking point, but be aware if you want LivePremier and you want SDI outputs, you do not want an RS model. That's RS configurations are stock configurations. HDMI, 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 RS4, HDMI, 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 HDMI. You can get SDI outputs. That's what these two are for, the C and the C+. In the simulator, you can change around anything you want. So if you're a rental company, you have an RS4 and you want to reconfigure it, pull up the RS4, the internal hardware is correct, and then you can just change the output card to be whatever you want. But if you're ordering an RS4 and you want a different connector on it, you're varying more towards this C+ over here. If you're buying new, rental companies like having lots of output options, so they will usually buy a stock frame and then all of the connector option cards. But if you're doing an install, you probably don't want to have extra cards lying around. Look at the C and the C+ as your options for purchase. So RS4, I'm just going to make, let's go to an RS2. That's a single VPU, 40 million pixels, has 2 rows of input connectors, 2 rows of output connectors. I'm going to make one of these output connectors an SDI, 12G SDI. So I do that, I can save this. I have to save the configuration in order to start the session. Start the session. Yes, I want to allow access. I'll do it live. Sorry about that, but Internet Explorer is not playing nice on this laptop. I've had a lot of internet laptop things today. So, native backgrounds. Images. So this is in the pre-config section. These are images. These are your image slots. They have capacity. They can be a capacity 1 or a capacity 2. Our 2560 by 1600 is a capacity 1. So a native background image would be a capacity 1. I'm going to pick an output connector. Let's see, which output do I want to use? Screens. So I'll make it screen 2 as my output. So images, I'm going to pick an image slot. Let's use 5. And the one thing, you can do 2 things in the pre-config. You can set the input capacity, or the image capacity, so 1 or 2, dual link or 4K. And is this a background output? Yes. So I'm going to make this a background for output 4. So it says screen 2, output 4. This is the native background image source. Apply that. Then I go to native backgrounds, screen 2, background set 1. What are my options? On this connector, my option is image number 5. I have now made a background set. In the library, here are all of my images that are stored on this machine. They are literally stored inside the machine. So let's take 2560 by 1600. So let's just take something different than that, and I think this one. So I think I'll do the Aqualon. So images, 1, 2, 3, 4, 5. So currently I have this camera 2 graphic is available. So if I go up to screens, let's get rid of all of my screens and just put up screen 2. Let's just put up program so you can see it better. And then here are my input tabs. So I have inputs, I have graphics, preview and program, and then I have background sets. And it shows me the background set for whatever screen I have selected. This is in the input slot, so I can drag that over, and there is that input is a background for that screen. So that's how to do a native background image. Now, some of the things we've got in here, because it's that slot, remember. So if I go to images, I change this, and let's say I change it to this guy. Then I go back to screens. The native background has changed. So it's the input slot is the native background, not the physical image. It's whatever is being assigned to that holder space. So I changed it, and it was in use on the screen. It's going to change on the screen. So we selected the screen. So yeah, we can go back to the PowerPoint. So what we did is pre-config images, selected the slot, assigned the slot as a background output, and then in backgrounds for that screen, we picked a background set, selected the output, selected the output connector, we selected the source. So here in background set, starting up here, we picked the screen, we picked the set, then we picked an output connector, and then for each output connector you have an input, which can either be a physical input or it can be an image, depending on how you've configured it. And then, so we have our 2560 by 1600. Here is a screenshot of what that 2560 by 1600 looks like with the native background set. So we've got two 1024 by 768 screens and one that's 800 by 1080. The last bit here in this example is a mask layer. So one of the things that can be really handy is creating a mask that's literally just a PNG with a transparent background and laying it on that top layer so it covers everything. And again, remember, my top layer in this example is a capacity 2 4K layer. There are no test patterns yet that show AOI as far as I know. And William or Brian, if you... Yeah, the simulator with Brian, the Chrome will work with the simulator. The problem is on that laptop, the native or the default web browser is still assigned to Explorer. So that's a problem. Yeah, and William is correct. That one probably doesn't have the latest Edge version because latest Edge is actually Chromium in the background. So that's an issue on that laptop configuration. It's not an issue with the simulator. It's just the simulator is just grabbing the default web browser, and I haven't changed it from Edge. So there's no easy test pattern that allows you to do, here's my AOI inside, or here's my canvas outputs inside a screen. You could set test patterns on the individual outputs, but then you can't see. I suppose you could do outline. Yeah, outline would work, wouldn't it? Yeah, so you'd have to set outline. I'll show you that in a sec. So here's how I did a PNG, even this black line in the middle. So this is a PNG. All this black area is a native, is a PNG with transparency. This is working in the simulator, so you can throw this an image on a layer and it shows up. And then the test grid in the back, the color bars and gray grid pattern, that is an image on a layer. So there's a layer 1 with a single image, and then layer 4, the top layer in our stack of layers, has this PNG that blacks out all of the other sections. William mentioned the PNG mask is really handy if you have curved LED, like you're using squares and somebody wants to mask it to a circle or a triangle, or they want to turn, a giant group of Lego squares of LED, and they want to turn it into a circle. You can put a circle on the top layer and it gives you a nice circle edge even if the scenery isn't going to where you exactly wanted it. So this is just how to use a PNG as an image. So what I've got here is an actual PNG loaded, just a graphic loaded into a layer, and then this PNG with transparent background loaded into the top layer. And that's how to use a mask. Test pattern can be set to show the AOI. Ah, thank you. Let's take a look at that. Outputs. Pattern. Ah, yes. But where does that pattern, so turn that on, turn that on, does that show up in the multi-viewer? Because I don't think it shows up in screens.
What multi-viewer tab?
Yeah, because you don't get, so if I'm looking here,
on the left menu column, there's a multi-viewer further down where you can see the active. Yes, nothing there.
right. So the test pattern will show up on the output, So you can set the AOI correctly, but does it show up in, yeah, it shows up as inside the AOI, but does it show up on here? So screen, so if I do screen 1, output 1, because that's on output, so I can do canvas, screen 1, out 1, so that's over there. Which one of these has? Yeah, so if I do, oh, screen 2, give it an AOI. Let's make screen 2 smaller.
You have a pattern on?
I'm going to do that right now. So I did the AOI on screen 2.
William says it does not.
Okay. So that was the,
So just the outlet.
just, it shows up on the output, but it doesn't show up on the web RCS. So what I was doing is using that to build a test pattern that I can build my squares and build my layers to and kind of get them close even when I'm offline. User keys or palettes or templates or memories. So screen memories, not master memories, but just screen memories that can be used anywhere. And filters turn into the ability to save things like layer position, layer size without saving the content, or layer borders without saving the specific layer. Lots of different options for user keys. Here is the walkthrough on how to do that. So screen memory, turn a filter on, arrange the layer where you want it, save it, and you can select from preview or program, select which screen you want to save from, which categories you want to save, and then save it. Sorry about that. So here is our example screen, our 2560 by 1600. I've got a layer on the left and a layer on the right, and they're all positioned correctly and sized correctly. And then what I'm doing is I'm going to filter saving these memories. So I'm going to save from preview, which is the screen we're looking at. And this is where are you going to save it, which screen are you going to save from. In this case, I was up to screen 5 already. What do you want to save? So I just want to save position and size of all the layers. And I dump them into a layer key. And then here is a close-up view of what that looks like. So I saved it, and this little icon, the little funnel icon, just like it is in a lot of the Microsoft programs, that says, hey, you're filtering things. So it tells you, hey, you've applied a filter to this screen memory, and this is a screen memory, not a master memory. Screen memories can be used on any screen, so you can save them from anywhere and use them anywhere. And so on this one, I had saved the position and size of all of the layers. And you can save one layer. So I could put layer 1, layer 2, and layer 3 as separate keys and stick them where I wanted. The nice thing is we now have, I'm double checking on me, in screen memories, ouch, scroll, more scrolling, Still more scrolling. Ran out of screen. Yes, we have 1,000 screen memories to be used at your leisure. So you're probably not going to run out of screen memories on LivePremier. Thank you, Analog Way. Excellent move on that one. So let's do exercise 2. So 4K content, 6 processors, 1920 by 1080 each processor, and sources can be either specific to each output or they can be stretched across all 6 of these LED screens. For anyone who has taken our other screen processor for LED class, these are exactly the same examples. And we did that on purpose because we can show you how LivePremier is different than some of the other screen management hardware. So 4K content, so there's a 4K, that's a capacity 2. 6 processors that are maximum of 1920 by 1080. And sources have to either fit in these windows or stretched all the way across. So when we say it's got to stretch all the way across, and it's a 4K source, that means we have a capacity 2 layer someplace. Here are the XY coordinates for all of these different windows and their pixel size or associated pixel size. So 00, 1280, 0, and 2816, 0. They go across the top. And then 0, 1392, 1280, 1392, and 2816, 1392. So they're all across the bottom. These are all 768 high. It's 1280 by 768, slightly bigger than 720p. All of these are well below capacity 1 sizes. These are all tiny. So the question is, kind of like the will it blend, will this work? 1 VPU. I need 6 capacity 1 mix layers and 1 capacity 2 mix layer. So an RS1, if you look in the simulator, an RS1 has 1 VPU. 1 VPU is 4 4K mixing layers or up to 8 capacity 1 mixing layers or a combination. So 6 capacity 1 mix layers and 1 capacity 2 mix layer. That is doable in 1 VPU most of the time. Will this work in an RS1? No, not the way we've laid it out. It uses too many resources. Let's look at why. Now, I'll let you know right now, I specified an RS1 with 1 VPU because this is showing you how the VPU allocates across outputs. So 1 VPU with 4 outputs. I'm going to zoom in here. I have 4 outputs. I have 8 capacity 1 mix layers. I have 4 capacity 2 mix layers, just like we said it did. Nothing wrong there. Can I do this with 4 outputs? Yes, I can. However, as soon as you add the 5th output, you restrict the flexibility of the VPU. And once I add not even the 6th, just add that 5th output, now I have a maximum of 4 capacity 1 out layers and a maximum of 4 capacity 2 layers. So our example of saying, hey, I'm going to do this with 6 single HD, not even capacity 1, 6 sub capacity 1 processors and 6 outputs on this frame, it's well below the 40 million pixels the VPU can handle, but the 5th output is restricting what you can do. instead of doing this with 6 outputs, because we're talking it's a 4K screen, it's a 4K source, we said that at the front, let's do this with 1 capacity 2 output. So the same RS1, 1 VPU, that's all we've got. But we're going to do it with a capacity 2 output. As soon as we change it to a single output with a 4K capacity, we are now back to our 8 single capacity layers or 4 capacity 2 4K layers. So I can do my 6 mix layers, 1 on each of the 6 LED elements, and 1 4K layer across everything, just by going from 6 outputs that are only doing HD and going down to 1 capacity 2 4K output. Key factor in LivePremier is rethinking which LED processors are you using, because the connectors are capable of a lot more pixels individually. You probably want to look at a lot more events with 4K LED controllers, like the top of the line Brompton, like the 4K processor from Novastar, rather than using a lot of HD LED processors. The LivePremier platform is 4K native and maximizes its pixel space when you start doing 4K destinations. So if I go from 6 single outputs to 1 4K output, I can do this no problem with an RS1. Now an RS1 has 2 lanes, 2 rows of output connectors and 2 rows of input connectors. I have all of the layers I need to do. Using a single capacity 2 output, it's a more efficient use of resources. So either upgrade your LED processor to 2 dual link processors, you're still below your 4 or less, you'll still have all that flexibility, and link them as a screen, or use 1 4K processor and do it with 1 connection. It's 1 box, 1 connection, much easier, much simpler. So this is with an RS1. There's a LivePremier even smaller than the RS1 called the RS Alpha. Has 1 VPU, has 2 input cards, 8 inputs, has 1 output card. Can I do this screen with 1 output card in RS Alpha? Now, the original configuration was 6 outputs. There's no way to do 6 outputs off of an RS Alpha. It only has 4 physical output connectors. With an RS Alpha, however, because I'm doing a capacity 2 output, absolutely, not a problem. I'm using all of the layers. Only has the 6 mix layers, the 6 capacity 1 mix layers, the 1 capacity 2 mix layer. So there's no layers left. You've got nothing else. You've got 3 output connectors. You can use them as AUXes. AUXes do not need any VPU power, which means your downstage monitor can be an aux out off of one of the other 3 output connectors on an Alpha and show the entire screen. So it can show your entire LED screen at 1920 by 1080. It'll downscale it and spit it out, no problem, without using any VPUs. So this 6 processor screen with an older style system, you can do with the bare minimum, smallest LivePremier platform and get more out of it, because you can do the full 4K screen and your downstage monitor and a green room monitor all at the same time. And you have 2 multi-viewers, and you get the new HTML5 WebRCS, and it works very quickly, and it's small and nice and friendly. So your 3 remaining aux outputs don't use VPUs, and each of those aux outputs could be up to 4K. So you can fit the whole 4K canvas in it, or a single output, or your slides. If you bring your keynote presenter view that I'm looking at here, You could bring that in, route that to the aux as an input to an output on an aux, no problem. So even with an RS Alpha, this screen that normally used to take 2 output cards and 6 output connectors and 6 processors is 1 connector, 1 HDMI cable, or 1 12G SDI cable. Now, our next slide here is the how I did the layers. So I have 6 capacity 1 mix layers, and I've positioned them accordingly. And in here on the web RCS, you see layer 1, 2, 3, layer 4, 5, and 6. In the corner, it shows which input. I actually have a bunch of separate stills for each of the inputs, all lined up, all set up, and then I have above it, I have one last layer that sits on top. That's the 4K layer over everything. So yes, you can do it with even the smallest LivePremier processor. Exercise number 3, 2520 by 1130, 1176 vertical, and you have 2 Novastar 660s. Again, Novastar 660, not the 660 Pro. Very common, same as the 600 basically. Very common DVI or HDMI input, 1920 by 1080, 2.3 million pixel processor. So that's our canvas space. That's our total canvas. Old method, 1900 by 1200 resolution. That covers the 1176 high with a standard VESA format. Split the wall, and away you go. So the question that comes up here is, where do you split the wall? Let's take a look. First answer, split it in half. Depends on the pixel space of a single tile, because you can't have 2 different processors controlling 1 LED tile. So the tiles in this case are 168 by 168. They're a 2.8 to 2.9 millimeter from some manufacturer. A bunch of people make tiles that are this size. The wall is 15 tiles wide and 7 tiles high. So we're going to split it straight in half. One quick hint, anytime there's an odd number of horizontal tiles, you're not going to split the wall in half, because you're going to split the tile in half, and that doesn't work. In this case, we end up splitting the tile right in the middle of tile number 8. So, I am going to take a second to make the simulator work. Woohoo! That works. Come on, Chrome. Okay, so let's go ahead and do this in the simulator. So if you go ahead and throw me up, beautiful. This is the simulator. I just had to go in and change the default browser to Chrome because Edge on this laptop is not updated. So 2560 by 1600. So we're going to go screens. I have this set here as an RS, 2 outputs. So this is an RS1 probably. I forget what it was. Let's take a look. Simulator. Yes, I have this as an RS1. So output 1, we're going to take these two, we're going to screens, screen 1, turn the screen on. 2 connectors into the screen. 1, 2. Got to add a layer to a screen. I'm going to add 2 mix layers, 1 capacity 2 layer, apply. So that gives me the output connectors I need. Next, canvas, pick the screen. First thing I'm going to do is change the screen size. I'm going to go into custom, and this is 2520 or 2560. I have 2520 by 1176. I have 20, oops, by 1176. Got a big screen. Yes, I know the outputs are overlapping. Take output 2. So, output 1, we got to make it 1200 tall. And then we're going to come in here and we're going to go custom. First, it's 1176 tall. And we're going to make this first one, it's going to be 1848 wide. And that's because that's 11 tiles. So 1848 wide. Number 2, first we're going to set it at 1848. We're going to change it to 1200 high. We're going to do custom down here. We're going to make it 1176 tall. So this is .652 wide. So there is our left half, right half of our screen. And if we look under screens in our simulator, there is our setup. So that's how to do these 2 screens. 2 outputs. Now remember, we're taking up 2 physical output connectors to do this screen. But that's 2520 by 1176. 2 output connectors. We did the canvas. We did our AOIs on both of them. AOIs work fine with any kind of connector. Super fast, super easy to do. There's our AOI on that one. There's our AOI on that one. And the seam is now the seam between 2 cabinets rather than being in the middle of a cabinet. If we go back to the PowerPoint, and so here's our 2520 by 1176. Set the outputs at 1200 so that the outputs are bigger than the vertical space you need, and then just use AOI to crop it down. Don't have to do anything custom. But instead of using AOI and 2 connectors, we could do this with 1 output, 1 processor, and a custom format. So let's go ahead back and we'll do that over on the simulator. Yay. So first thing, custom formats. 2520. And that's, I'm just giving it that as a name. Doesn't matter what I choose up there. Turn on reduce blanking. I always run at 60 Hertz for LED if possible. And because we're not playing nice with anybody else right now, we can do that. Horizontal timing, 2520. Vertical timing, 1176. Right? Yes. Check. Capacity 1. So instead of using 2 connectors at 1920 by 1080 where you're only using half of what they're capable of, we're going to use one of those connectors at what it's capable of. I'm going to save that as a custom format. I'm going to go back to screens and auxes. I'm going to create a new screen. I don't have to change the output connector capacities because we've already figured out this is a capacity 1 screen. I could not do this on these bottom connectors because they're SDIs and can't put a custom format on an SDI. So, new screen. Enable the screen. Add a connector to it. There we go. Add a layer. Capacity 1. Only have to do capacity 1 layers. We'll give it 1 layer because we're being stingy. Go to Canvas. Pick our screen. Here's our output. Go to our selection. Go here, pick our custom format. We're done. Don't have to do AOI, don't have to do canvas arrangement, don't have to worry about moving things around. Single connector, capacity 1. It's the lowest capacity capability on the connector, so you're going to get maximum use out of it. You only need capacity 1 layers as long as your sources are capacity 1. That's dual link or less. Here we go. And if we look at our screens, I'm going to shut off screen 1. There is our screen. There is our layer. We only have our 1 little layer on it. So if we go back to PowerPoint, here's what we just did. Went into custom format, built a custom format. Again, with custom formats, CVT, it's fast and easy. Reduce blanking gives you a little bit more pixel space, and it's going to maximize the connector capacity usage. Put in the horizontal, the vertical. Make sure that the vertical refresh rate is the refresh rate you want it to be. Everything I'm doing, I do at 60. That's what we're doing today. If you're doing a bunch of, if you're dealing with broadcast and you have to run at 5994, not a problem. Just make sure you set that rate correctly before you build your custom formats. Capacity 1, we saved it. We don't have to worry about AOI. It's a single input. So again, if we needed a native background, there's only 1 input coming into this. There's only 1 output. So we can do that very simply. You've got to use HDMI or DisplayPort because they're the only places the custom formats work. And we're not going to use DisplayPort because there are a very limited number of LED processors or controllers that use DisplayPort. So I just stick with HDMI. Can you adjust multiple AOIs at once? Yes, yes you can. Because in our next example, it's going to save you some time. If we go to simulator, please. So if I go to Canvas and I pick screen 1, I'm going to mess up screen 1. So I did, I can click on either one of the 2 screens and they're highlighted. Control, click on both of them. I'm going to select both of them. Go to selection. I can now change the AOI on both. Once I get below where it was, you can see I'm moving both of them I'm going to make them both shorter. So I'm just changing one, or I'm changing both of them simultaneously. You've got two AOIs that need to be the same size. Select both canvases, or select both outputs, set the AOIs, and then select the one and position it where you need. So once I've got them sized conveniently, you can also copy and paste. So I could pick this AOI, set it to a size I wanted. Copy is this icon up here. Click that, select this output, and paste. So copy, paste. Really fast, really easy, works really well. And then just set the position, so I can change the AOI start position. I can also change the start position of the output in relation to the canvas. So this position is where the output is inside the canvas space. This position, once your AOI is smaller than your raster, is where the AOI is positioned inside the raster. So see how out the word moves across the visible raster. This position up here is going to move the whole raster. So that's the two different H and V positions. So yes, you can adjust multiple AOIs at once. Exercise 4, M29 tiles. What is the resolution of the side walls? What's the resolution of the center wall? And how many processors? So where do we find the resolution of the M29? Hey, Luke. Sorry, my chat window is dying. I'm going to plug it in. So the fastest way to find the resolution of any LED tile pretty much in the rental industry is FidoLED is our friend. So go ahead and look it up in FidoLED. The M29 is an absent tile. It's a 2.9. Pretty much all the 2.9s are going to be roughly the same. So as long as you know there are 500 by 500, you're fine. So M29 is 168 by 168. What is the resolution of the sidewalls? Well, 168 times 6 and 168 times, they're 11 high. So they're 1008 wide by 1848 tall. Center wall is 15 wide by 4 tall. A quick note on FidoLED. FidoLED normally defaults to starting with the first tile at 0, 0 when they're counting. Notice mine started at 1 and went to however many. Personal preference. You can change the start number in FidoLED of your PNGs. That's where these came from. Center wall, 2520 by 672. How many processors do you need? 3. And to do this, because these are 1848 tall by 1008 wide, well, if those were rotated 90 degrees, they'd be underneath 1920 by 1080, so they're a single output. So that we know that even rotated, that's going to fit into a HD pixel space, not even a capacity 2 pixel space, or capacity 1 pixel space. The center one is 2520 by 672. We just did 2520 by, what was it, 1176? And that was a capacity 1. This is even shorter. So absolutely only a single processor is needed. Maximum. So you can create 2 custom formats. And the question is, will the center screen work on a capacity 1? We're going to find out. So we go over to the simulator. I'm going to go in here to screens first. So screens, I'm going to pick this screen. I'm going to delete that layer from it. I'm going to delete that connector from it. I'm going to apply that to free up that one. And I'm going to go here. I'm going to delete those layers. I'm going to delete those outputs. I'm going to apply that. So now I have no screens left. Nothing is applied to a screen. Formats. So 1008 by 1848. Same way we did these others. So 60 Hertz is my vertical refresh rate. I'm going to give this a name of 1008 just so I can find it. Horizontal 1008. Vertical is going to be 1848. Enter. Check that. Yes, it will work as a capacity 1. Where do I want to stick it? I'm going to stick it on number 3. Save. The other wall, 2520 by 672. Same thing. So I'm going to do 2520 V2. It's 2520 wide. 672 tall. Check. It's also a capacity 1. Where do you want to stick it? I'm going to stick it on number 4. So there's 2 custom formats. What capacity do I need for the center screen? I need a capacity 1, so dual link or better. So any processor that handles dual link will handle that screen just fine on one connector. Basically, if you want a quick check, is 2520 times 672, the horizontal times the vertical. If it's less than 2.3 million pixels, it'll probably work. Use the calculator to double check, because sometimes there are timing constraints that you get around, that you get beyond, that it won't work. But generally speaking, anything at 2.1 million or so pixels will work as a lower capacity. So next up, we're going to create 3 screens and add 1 layer to each screen. So screens, go to screens. All these are capacity 1, so we don't have to go and change connector capacity. So screen 1, enabled, add that, add a layer. Go to screen 2, add that, add a layer. Notice that I'm stacking up everything over here on the right, so I can do it all at once. Screen 3, enable, add an output, add a layer. So I've got 1 layer on each screen, and then I can just apply to all of them all at once. So I have screen 1, screen 2, screen 3, everybody's got 1 layer. Canvas. So add the set the canvas to the pixel size, or the total space. So screen 1, out 1, selection. Screen 1 is that one. And just get rid of the custom AOI. Screen 2 is going to be the horizontal one. Select the output, do the drop down. That's 2520 V2. Change that, and we have a widescreen. Screen 3, select that, select the drop down. That's that one. There that is. If we go look at our screens, turn on screen 1. And what did I do to screen 1? Sorry about that. No, still didn't set.
Auto on your screen canvas.
Yes. Thank you. And there are 3 screens. This layer is just hiding in there. So we have 3 screens. But we have 3 screens. So if you do the PowerPoint, yay. So we just built the 3 screens, 3 custom formats. Everything is great, except there are 3 individual screens, and there's no easy way to stretch a single input across all 3 of those screens. You can do it. You could assign the same input to layer 1 on every single screen, and then manipulate each layer differently so that left-hand side was magnified to the left and cropped the center screen and then did the right screen, and you could make it work, but it's not easy. Not saying it can't be done. Easier way is to make a large free canvas with negative space with 1 screen and 3 outputs, and you can then do a mix of capacity 1 and capacity 2. We're going to put capacity 2 on the bottom, we're going to put 4 capacity 1 layers on top of that, and a capacity 2 layer on the top. So that way I can have a single input that stretches across everything and put a pip on top of them, and then I can have another single input that stretches across everything on top of that. Because remember, there is no Z order adjust, so the way we assign the layers is how they are going to stack. I have been told Z order is coming down the road, but for now, the way you assign the capacity of the layers, that's how the layers are always going to be. So your layer order is critical. I can still do that with here. So let's go ahead in and we will do this because I've got one more output connector, so we'll do it on here. First thing we have to do is figure out what our total canvas size is. So arbitrarily we made the canvas size 5,000 by 1848, and then we'll just position the outputs accordingly. So if we go back to canvas, we're going to go into screens. Hey, Jack. So screens, and we're going to eliminate this screen. So I'm going to delete that and delete that. And then we're going into this screen here, and I'm going to delete that, and I'm going to delete that, and then I'm going to apply all that. And I'm going to go to screen 1, and then I'm going to apply that one, and I'm going to apply that one. I'm going to delete that. I'm going to do a capacity 2 layer, and 1, 2, 3, 4, I think I was going to do, yep, 4, and then I'm going to do one of those. So that is all of the capacity of this VPU. But I have a single layer for everything. I have a background, a bottom layer that's a 4K that stretches across everything, and I have a top that's a 4K that stretches across everything, and I have an extra layer. I have an extra pip that I can throw wherever I need to, whenever. Apply that. So we've applied all our layers. Here's our layers available. We have no layers left, but every single output connector is still available as an aux. Go to canvas. We only have screen 1, so now we have to do a custom canvas. we decided this canvas size was 5,000 wide. 1, 2, 3. And the canvas is 1848 high. So that's building our custom canvas space. Output 3 is going to be over here. Output 2 is going to be there. Output 1 is here. Now we still have to apply our custom formats to get our, or we could do area of interest, but the custom formats are easier. They're still hanging on to the custom formats from last time. So this one is 1008 by 1848, and it's at position 0, 0. Perfect. This one is all the way over against that edge. It's still 1008 by 1848. Perfect. This one, we need to position it correctly. And I have to zoom in on my notes to make sure I put it in the right position. And it's at 2520, position 1280. Okay, so this one I have to position correctly, and that's position the output within the raster. So select the output, do selection, and I'm pretty close just by eyeballing it. It actually wants to be at 1280. So 1280 is the center line of where that one needs to be. So that's the upper left corner of that. So I've got my 3 outputs positioned inside the canvas. LivePremier does an excellent job of working with negative space. So I can do a layer that stretches across here, and it will jump. The layer will span all of these negative spaces freely, and you can freely position the outputs inside that canvas. So super handy, super easy. And then I go look at screens, and here is our screen. So the next piece of this equation, we've got everything positioned correctly, but we need to put the layers in place where we need them. And again, I'm only working in the simulator. So layer 1 is the bottom layer. It's a 4K. Not worried about that. Layer number 2, and I'm going to get rid of program. So I'm only working on preview. So I'm going to select layer number 2. So down here, I'm going to keep items in the screens, and I'm going to do unused visibility. So I get rid of anything that's not visible. So I'm going to pick layer 2. That's layer 2. That's layer 1. Delete key will delete content, so I can select the layer. So now I'm just grabbing the one layer, and I don't have to worry about anything that's not unused is hidden, and I don't accidentally grab it. And I constrain the layers inside the screen so I can't accidentally shove the layer off the screen. If I unclick that, I have free position of the layers, which means because I've got one layer that's all the way over here on the left, if I turn that on, it makes it a lot easier to go, oh, that's where it's supposed to be. So this layer size is 1008. No. Position is 0. Size is 1008. And it's 1848 high. And their positioning is by the center. So now I'm grabbing it and putting it there. Now I'm going to put 1 here. I'm going to make 2 that top one. I'm going to make layer 3 the far right side. So I just dropped input 1 into layer 1 just so it stays so that it's not an unused layer. I'm going to grab layer 3. I'm going to put input 3 in it. And yep, actually I want, that's 2, 3, I want 4. So I'm going to take layer 1. I'm going to go size copy. I'm going to go to layer 4, size paste, and shove that all the way over there. And then I'm going to do bottom layer, layer 3. I'm going to put input 2 into that so I can see it. And this one is 2520 by 672. So 2520, enter. 672 on the height. And then position 0. Actually, nope. There. So they are positioned correctly and sized correctly. Now I want to save that as a memory. So memory, save. That opens up this window of what do you want to save? Well, from preview, I want to select screen 1. And I don't want to save everything. All I want to do is save the position and size. And first I'm going to save all 3 layers so I've got them all done. I don't want to save any of the other layers. So this is layer 2, layer 3, and layer 4. And I'm going to save this as master layer. And click save. And there is my master layer saved. So, and it's got the little icon on it. So if I move all of these around and I go recall master layer, it puts all 3 layers back in space. I would also likely go in and save each layer individually, so I have layer 1, 2, or layer 2, 3, and 4 saved in their home position individually, so I don't have to do this every time. But that's creating basically a user key type or a memory, filtered memory, to get the layers in position over this large canvas so everything is positioned correctly. Okay, back to, and the constraints I used, I got rid of, I did hide the other items and trap the items inside the screen so that it was easier to keep everything without getting lost. And then you can create a native background set. So I'll show you how to do that, and then we'll look at the slide and see what it looks like. So a native background set for this, we would take 3 images. So the first thing you have to do is make sure that images in pre-config are set as native backgrounds. Each of these is a capacity 1, so it doesn't matter which one. None of these are assigned to anything. So image 1, we're going to make it a background for, and it's output specific currently. So image 1 is going to be output 1, image 2 is going to be for output 2, and image 3 is going to be for output 3. Apply. So those are set as, if you look at the image slots, they're capacity 1, and they are assigned as background images for those specific things. Go to backgrounds, select a background set. Now you see the overall canvas, you see the position of each piece, and when you select an output, you then have the option of what do you want this background set to compose of. So that's going to be image 1, that one's going to be image 2, this one's going to be image 3. That's now a native background set. In the images, I don't have anything in the library on the simulator, so I don't have anything to drop in. But if we look at the PowerPoint, I'll show you what that looks like. So it's exactly what we just did. The PowerPoint slide is the same thing. Single image for each output. The pixel accurate PNGs I used in this slide all came from FidoLED. And we have background set 1 showing 3 images. Again, in the simulator, the background sets show up on the WebRCS in the simulator. So you can do all of this with the simulator using the PNGs, and it works. And when you save a configuration from the simulator, you have the option of saving those PNGs with it, those actual files, the image library. And when you load it onto ShowSite, it will load all the stills that you've been working with into the unit for you. AOI test pattern, we talked about this. So I use the pixel accurate patterns here to lay out where the layers go when I'm working offline in the WebRCS. So that's what that's for. Exercise 5, 4,000 by 2,000 pixels. What's the connector capacity going to be? Use the custom format calculator to take a look at what that would be. 4,000 by 2,000, 4096 by 2160 is a cinema 4K resolution, so 4,000 by 2,000 is probably a capacity 2. Use the calculator. Yep, it's capacity 2. One output. Can do 4,000 by 2,000. 4,000 by 2,000 will work on SDI, HDMI, and DisplayPort all because it exceeds the capacity of the SDI 12G connector, or it's less than the capacity of the 12G output, so you can use an AOI on a 12G and get it on a single 12G feed, which is great if you have either a UHD Junior from Novastar, or I think it's the SX40 from Brompton. Both of them have 12G inputs. Away you go. So 4096 by 2160, select your output, go to selection, set the resolution where you need it, and the pixel size on, so I can do that over here on the simulator because this is really simple. So here in the simulator, I'm going to pick a 3G output, or 12G output rather. So this output connector, I need it to be 12G. Got to change the capacity to 2. Apply that. So that's now a capacity 2 connector. Screen, I'm going to create a screen. I'm going to remove a layer from this screen because I have no layers left. Let's remove capacity 4 layer, apply, because I need a layer. And take this connector, put it in there. I'm going to apply one 4K layer, apply, canvas, screen 2. Here we go, selection, what size is this going to be? Up here, 4096 by 2160, region, custom, 4,000, 2,000. And again, because this is smaller than our raster, you can move this around. It doesn't have to start at the upper left corner. And then if we go look at screens, and we look at screen 2, here is our screen 2 with our 4K layer. Here's our preview program. So there's our input 1, input 2, 4000 by 2000 pixels, all on our screen. Area of interest, fastest, easiest way to do that. Exercise says 6000 by 2000. How many connectors do you need? So back to custom formats over here in the simulator. And I'll just pick another empty block. 6000 by 2000. Most people would say, oh, you need 2 4K outputs for that. Well, let's see what we do need. So I'm going to just call this 6000, tab CVT, because I just want to do it quick, 60 hertz, reduce blanking on, 6, 1, 2, 3, 2, 1, 2, 3, check. Oop, can't do that. Why was I able to do it before? Oh. I'm looking at my notes and wondering why I could do this, and then looking and reading the typo on my notes. So 6000 by 2000. So that's going to come back and give us an error.
Reduce the rate.
Yeah, I did a 4000 by 2000 pixel space. So you could do, as you reduce the rate, let's go way down. You can make that work. So frame rate has an impact on the number of pixels you can fit in a pixel clock. Same is true on the LED side. Reducing the frame rate, the video frame rate, the vertical frame rate, increases the number of pixels you can put on an output port, generally speaking. Most processing systems work that way. So by playing with the frame rate, you can get more pixels out if that's going to be creating an acceptable image for your end client. So 6000 by 2000 down at 30 hertz works fine. That's a capacity 2. At 60 hertz, not so much.
Might work at 50.
Yes, let's try 50. Nope. 30, it definitely works. 48, I don't think it'll do. And all I'm doing is changing the frame rate and just hit enter to get it to take the new rate. So by changing the frame rate, you can get increased pixel capacity. In LED world, we know that lowering the frame rate also increases the likelihood of flicker, because the entire screen will turn into a giant strobe light. So we got one more example in our slide deck. By the way, we only have 4 more slides to go. So one of the huge advantages of LivePremier on a single canvas, without doing anything fancy, the output resolutions on a single canvas don't have to be the same. They don't have to be the same connector. You don't need the same resolution, and they don't have to be the same capacity. They do, to stay in sync, have to be the same refresh. When I ran this example by the team at Analog Way, the answer I got back was, yes, this will work as long as everybody is running at the master clock rate. So don't run somebody at a weird clock rate and this would work. Now, whether or not it's going to work on the LED side is a question. So here's what we're doing. Got a large festival display. It's 4,000 pixels wide and 5,000 pixels tall. And your LED vendor subbed the processors. You were going to get 3 exactly identical processors, and they sent 4, 2 of Model A and 2 of Model B. So 2 of the processors are 3G SDI only, and 2 of the processors are 4K with only HDMI connectors. We are assuming the no-name processors are all non-scaling processors, so that they don't have any scalers that will impact the pixel clock coming out. So they're non-scaling processors. We're going to do all the scaling in LivePremier. Can we make this work? 4,000 by 5,000. So 4,000 pixels wide, 5,000 pixels high, 2 3G outs, 2 HDMI 2.0 outs. Yes, we can make this work. And I'm pretty sure I can do this in the simulator with my RS1. So I'm doing this with a tiny baby LivePremier 1 VPU output. So again, back to screens. Let's free up some resources here. So I'm going into screens, screen 2. I'm going to delete everything from screen 2. Screen 1, I'm going to delete everything from screen 1. I could go and reset and just start a new session, but I like doing the delete. Save that. So I have no screens assigned. Now I'm going to go to outputs. I'm going to go to this output connector and make it an output 1. Apply that because it's 2 3G outputs. And I'm going to do function F11 and refresh. So I'm just refreshing the browser. So we're at 4,000 wide, 5,000 high. So pre-config, screens. So 4,000 by 5,000. So I need 2 of these HDMI connectors to be 4K. So this one is going to be there, capacity 2. This one is going to be capacity, actually I'm going to use this one because they don't even need to be adjacent. Apply that. So 2 of these outputs are capacity 1, 2 capacity 2 outputs. Perfect. Screens, 1 screen. I'm going to put that guy in it. I'm going to put that guy in it. I'm going to put that guy in it. And I'm going to put that guy in it. Got to have a layer. I'm going to put a giant 4K layer. And I still have 3 capacity 1 and 1 capacity 2 layer left. So I can do a 4K source and I can do a pip on top of that. So I can do a pip at the bottom. That seems a little silly. Let's put that pip on top. So I have a 4K layer at the bottom, and then I have 2 pips on top of that that are up to dual link capability. Apply that. Canvas. Screen 1. So screen 1 is going to be a custom size. It's going to be 4,000 wide. It's going to be, if I can type, 5,000 tall. So there's our festival screen. 4,000 pixels wide, 5,000 pixels tall. Output 1. Selection. Let's just get rid of some of these errors. Just move stuff around temporarily. Where the heck is output 2? Output 2 is lost in space. Okay, output 1. We're going to make it a 4096 wide because the wall is 4,000 pixels wide. It's 4,000 by 2160, and we're going to go custom, and we're going to make it 4 1000 area of interest. We're going to make it 2000 tall, area of interest. And we're going to copy that. I got number 2. We're going to paste that. We're going to make this that. So we're 4000 by 2000. We're going to make it 0. And yes, that's too big an overlap. We're going to make this at 2000. So it's below that. Now output 5. Yes, we're going to make this a HD. So I just want, well, yeah, I can make it a project. I can make it a 1200. It doesn't really matter. So it's horizontal 0. It's going to be at 4000 down. And on the area of interest, this one is going to be 2000 wide. Oh, I got to make it not 1920. I got to make it a 2048. I got to make it a 2K. So 2000 wide and a 1000 tall. And that's where that is. I'm going to copy that size. Going over here, I'm going to change this one to a 2048. I'm going to paste the area of interest size. And I'm going, he's at 2000 over and 4000 down. And there we go. And there is our 4 output canvas, our very tall screen. I'm going to make this layer full screen. Center that. There are our inputs and our layers, and our screen is going to function on different outputs. Now the only thing that happens up here in the connectors, because I played skip a connector, so down here I have no layers left. So if we look at screens, I have no resources left in this switcher. So I can't make anything other than an aux. And if I go in here, this, I can make an aux. When you make a connector an aux and you make it larger than 4K, because auxes default to 4K as their pixel space, capacity 2. It steals from the things to the right when you make them larger. The reason to make them larger is because your screen is bigger than 4K. This screen is bigger than 4K. It's a 4K by, it's 5,000 pixels tall, so it's as wide as 4K, and it's almost 2.5 frames high. So it really needs a capacity of 6. The problem I'm going to run into with this is if I try, like this connector here, if I try, my only options in aux are 2 and 4, because it has to steal the pixel processing power of the connector to the right. Up here, this one says 6 as an aux, but that would kill my screen output. So I can't do a single aux out of this entire pixel space on this processing box because of the way I've laid it out. If one of these HDSDI outputs was an HDMI out, or one of these processors up here that's HDMI took a 12G in, then I would have enough to create an aux of the entire space on one connector. So that's the last thing to be aware with auxes is they steal connectors. They steal connector processing power. If I turn this one into an aux of 4 and do apply, you'll see what happens. Then this connector is disabled. So back to our PowerPoint because we only have 2 slides left. Good news. Okay. Currently, there is no screen test pattern. There are output test patterns. There's no single test pattern for a screen out. It's coming. It's not out yet. We're only talking about what is available today. There is no rotate function yet. That's why when I was doing the vertical canvases, I always created a custom format. When rotate comes, that could be an option, but if rotate functions by rotating the output and the image, then LED has to change how they wire things. When you use a custom format, you wire it like you would normally. You don't have to think sideways. There is no linking of frames available, so everything that you need input and output wise has to come from the one frame you have. So look at how many output connectors you need or how many input connectors you need. You may find you need more inputs than you need outputs, then you need a larger frame. There is no Z order adjustment, so laying the layers into your screens, the order you layer them and the capacity they have will determine what capabilities you have later. Pixel compensation in Canvas. This is a really interesting feature. If you could bring up the, yep, thank you, sir. So pixel compensation, it's down here in pitch. It allows you to set 2 outputs that are in the same canvas but have perhaps different pixel pitches, like I have an LED wall sitting next to a projector, and change the magnification or scaling basically of one or the other so that they work together. As far as I know, this is the first screen processor to offer that functionality as normal capability. I do not know if any of the others have it. Not saying they don't. I'm saying I don't know. It's in here. It's in Canvas. It has a very specific functionality, but if you're marrying 2 different pixel pitch LEDs next to each other and you want to put a pip over both of them, you don't have to manipulate the 2 pips separately. You can manipulate the whole output. Also, a projection output surrounded by an LED that has a different pixel per meter or pixel per foot. Same idea. So pixel compensation in the Canvas is a really unique feature that I think a lot of people are going to find very useful for enabling creative displays of low resolution and high resolution imagery. SDI outputs are HD or they're HD formats or 4K formats. There are no widescreen formats in the SDI connectors because there are no widescreen formats in broadcast. If you want to, thank you, we'll look at screens, auxes. So I made this one a capacity 4. So if I go to outputs, here. So this is a capacity 4, and we look at the resolutions that are available. So I have a 4K, I have a 2160, I have a 2048 by 1080, a 1200. If I change the rate down to 30, because that's where the basically these are these are the 6G rates down here. So they're 4096 or 3840 at 30 hertz. That's your 6G rate. But from what I've been told, you need to set the capacity at 4 in order to get those 6G broadcast rates. So they're just 4K pixel space at lower rates, lower frame rates. But there are no, these are all the options. There are no widescreen like some of the other manufacturers have a half 4K, so it's 3840 by 1080 on a single 6G cable. Those are not available. I did do some testing on the LED processing I have available, and they don't work on the input of those LED processors anyway, so not a big deal. But yes, SDIs are 4K or HD only, so there's no widescreen formats. Last slide. Thank you for sticking with us for 2.5 hours. Analog Way Simulator. New version, Mac and Windows native. There's a version for both. I've been working with the simulator since it came out a few weeks ago. It's really, really nice. You saw my issues with setting up the default browser. Chrome works great, and that's what I usually have as a default browser, so that's been working fine. Analogway.com, software tools, that's also where the EDID editor is. FidoLED, if you do FidoLED.com, it comes up from there. There was not just an update for the database, but there was an actual FidoLED update that I got the other day. If you solutions at Analog Way, solutions at Analog Way. Hey, we got a new email address. Solutions at evolvedmediagroup.com with a subject line, LivePremier for LED. We will send you this presentation. Can you please reshare the email and subject to yes. So the email, solutions, one word, at. I got it here. Solutions at evolvedmediagroup.com. LivePremier for LED. We will send you the presentation. Yes, there could be. So I'm going through some of the questions. Would there be a potential color difference if using mixed output connector types on the same screen? Yes, there could be, depending on how your processor handles color. So it depends on what color spaces you've set and what your processor does. But I can set all of them to the same color space, and then potentially no. It's going to be more on the output end. If we go outputs, so if you pull up the sim, and here in the simulator, so we've got color space. Here are my color space options for the HDMI out. And then down here are my color space options for the SDI out. So I can put full RGB on the SDI, and I can force full RGB 0 to 255 on the HDMI. So I can force the outputs to spit out the same color space. If your processor can or cannot take them, that's dependent on the processor. Most of them can. David? Would not work at the 2 pixel height. 8K at 1K. Yes, you can do 8K on a single output at 1K. So 8192 by 1080. Yes. 7840 by 1080 absolutely works at Novastar. I have done it. I have done it for a demo. So 3840 times 2 and 2160 divided by 2 on a single HDMI cable. And I am currently working on a project that is close to that. It's 7,000 pixels, almost literally 7,000 pixels wide, by roughly 1,000 high times several, because it's almost an 8K-ish screen. Reshare. Are there any additional questions? And if you have more that come up later, or you're trying something with the simulator, tech support at Analog Way is available. Obviously, they've been very helpful. They actually went through, looked over this presentation for us, made sure that we were factually correct. It was greatly appreciated, because 122 slides is a lot of stuff to go through 4 times. So their tech support is very good. We'll help you any way we can, especially if it's specifically with interfacing with the LED. Evolve handles both. We are a distributor for Novastar, so we have the Novastar product line in-house, and we have the LivePremier product line in-house, so we can actually put the two together and try things out. We've had really good luck. We've tried the 12G inputs on the Brompton and the 12G inputs on the UHD Junior. They both work without an issue. So if you've got any questions on applied use of these two types of products, so LED and LivePremier, we are more than happy to help out. Going through the questions. Yep. Trichrome with simulator, yes, that was just Windows B beating up. Jamie, yes, that and the just FidoLED.com works. Excellent. If there aren't any other questions, thank Mr. Eli over here for handling the switching, the interfacing, the streaming, the audio, and all of the other bits. Thanks to Anjay, William, and Brian at Analog Way for going through the presentation, for helping out with the chat, and for keeping us on the forefront of some really exciting technology. So, sum up, most of the examples I worked through today were on the RS1. The RS1 is the smallest, babyest LivePremier platform. So that last example that was 4,000 wide by 5,000 high used one VPU. The RS4 that we actually have running in this room has 3 VPUs. It can do 3 of that screen at once. So when people ask about, what box do you recommend for switching large LEDs? And these days, it's not because the LED screens are big, it's because the pixels are getting very small. We're currently working on a wall that is almost 8K. With this screen switcher, it literally is taking 1 and a little bit of a second VPU to make it happen. And I still have an entire VPU left over. So it's 12 4K processor outputs. There's 6 mains and 6 backups. So I have 192 Cat5 runs coming off of the LED racks, and it's only half of the pixel processing power of an RS4. Absolutely, hands down, the easiest to use large screen processor I have yet to use. So that's everything. Thank you very much for joining us. We're going to render this over the weekend, and this will be on our YouTube channel. We are open for questions via email. If you send us an email and ask for the LivePremier for LED, we will send you the PDF of the presentation. Have a great weekend, and hopefully we will see you in person soon.